You know, when we asked you to send in your most intriguing science mysteries, I don't think we are quite ready for
Yeah.
this research article you sent about Hessdalen Lights.
Oh, wow.
Those strange glowing orbs that people have been seeing up in the sky, mostly in Norway. But the real kicker is this article suggests they could be connected to something straight out of science fiction.
Okay.
Microscopic wormholes.
Yeah, that's a new one for me, for sure. Um, it's interesting, though, because we typically, when we think about wormholes, we think about these massive objects that are connecting galaxies, like something out of Interstellar.
Right.
But there are some scientists who are seriously exploring the possibility that wormholes exist on a much smaller scale, and maybe even right here on Earth.
Okay, so hold on just a minute.
Yeah.
Mini wormholes
Yeah,
under our feet?
potentially.
Before we even get to that, let's remind everyone what the Hessdalen Lights even are, because we're not just talking about some unexplained blips on a radar screen, are we?
No, not at all.
Yeah.
This is a phenomenon that's been observed for decades.
All right.
And studied. I mean, you have researchers like Erling Strand and Massimo Tiederani doing some really serious work on this, collecting data, analyzing light spectra. I mean, they're going all in trying to figure out what these things are.
So this article that you sent us, this is like adding a whole other layer to an already pretty strange mystery.
Exactly. It's basically saying, what if these lights aren't just some unexplained atmospheric phenomenon, but something even weirder?
Yeah.
And that's where the idea of micro wormholes comes in.
All right, so walk me through this, because the article starts with a pretty out there claim. It suggests that there might be this tiny, stable wormhole that connects the center of the Earth to the sun.
Yeah, the center of the sun.
Okay, so I have to ask this.
Yeah.
If there's essentially a mini-sun at the Earth's core, why aren't we all, like, fried to a crisp?
Right. Exactly.
Yeah.
I mean, that's the first question that comes to mind. It's like, if there's this insanely hot thing in the middle of our planet, how are we even having this conversation?
Right.
And this is where it gets kind of crazy. The paper argues that this central wormhole would be unbelievably small. We're talking micrometers here. Smaller than the width of a human hair.
So like a pinprick of unimaginable heat.
Yeah, you could think of it that way. And it's a pinprick so tiny that it doesn't melt the entire planet. But here's the thing. That central wormhole is just the start. The paper proposes that this wormhole could have branches, and these branches would be temporary, unstable wormholes that connect to random points in the Earth's subsoil.
So you're saying that these wormhole branches, if they exist, are like little cracks in space-time, and Hessdalen just happens to be sitting on a particularly active fault line.
That's one way to think about it, yeah.
Yeah.
The paper even suggests that Hessdalen might sit on something like an active BBL tank, a region where these wormhole branches are more likely to erupt, similar to how magma chambers under volcanoes lead to more frequent eruptions.
So if we run with this whole BBL tank idea for a minute, does that mean that Hessdalen is just unlucky?
Or lucky, depending on how you look at it, right?
Yeah.
I mean, imagine having a front row seat to potential wormhole activity.
Okay, so we've got these potential wormhole branches popping up like cosmic geysers, but how does a microscopic crack in space-time actually create something as bright and noticeable as these Hessdalen lights? I mean, we're not talking about some faint glow here. People are seeing these things with the naked eye.
Yeah, you're talking about a lot of energy being released.
Right.
And that's where the physics gets really interesting, because the paper suggests that even a nanometer-slimmest wormhole, we're talking smaller than a virus, could act as just this insane energy source.
We're talking temperatures hotter than the surface of the sun, right? How does anything, even something that tiny, contain that much energy without instantly vaporizing everything around it?
Yeah, that's a great question, and it's something the paper addresses head-on. Basically, they argue that while the temperatures involved are extreme, the total energy that's actually being transferred is still relatively small because of just how incredibly tiny the wormhole is.
Oh, okay.
So think of it like a single grain of sand that's been heated to millions of degrees. I mean, it's unbelievably hot.
Right.
But it's not going to melt a glacier.
It's like a super concentrated burst of energy, but on this tiny scale.
Exactly.
But how does that energy become light? What are we actually seeing?
So the paper proposes a model called photoionization. And basically what they're saying is that this intense radiation that's coming from the wormhole, it excites the air molecules around it, and that causes them to emit light.
So it's not the wormhole itself we're seeing, it's the air around it going haywire.
That's a good way to think about it.
Like a miniature aurora borealis, but triggered by a wormhole instead of solar winds.
Yeah, that's a great analogy.
Okay.
But here's where it gets even weirder.
Okay.
There's another mystery surrounding Hessdalen Lights, and that's their speed.
How?
Witnesses often describe them as moving incredibly fast, sometimes even faster than the speed of sound.
Whoa, hold on a second. If something is zipping around that fast, shouldn't we be hearing a sonic boom?
You'd think so, right?
I mean, that's like physics 101.
Yeah, it's a really good point. But here's the thing. No one has reported hearing sonic booms that are associated with Hessdalen Lights.
Okay, so now my mind is officially blown.
Yeah, it's one of those things that makes you really question what's going on.
How do you explain that?
Well, the paper offers a couple of really interesting possibilities.
Mm.
One is that the sonic boom might be happening, but it's happening in the ultrasonic range, so it's too high-pitched for us to hear.
So maybe we need to set up some special microphones in Hessdalen, something that can record those super high frequencies and see if we can capture these silent sonic booms.
That's one idea, and it's something the paper actually suggests for future research.
Oh, wow.
But they also propose another, even more mind-blowing possibility. What if the movement we're seeing is an illusion?
Wait, an illusion? How do you even have an illusion of movement when we're talking about something physical, like light?
Well, remember how we were talking about these wormhole branches constantly forming and shifting and disappearing? So imagine, instead of a single object moving through the air, what we're seeing is the rapid-fire sequence of these micro wormholes opening and closing, so each one ionizes a little pocket of air, creates a flash of light, and then disappears.
So it's like our eyes are being tricked, like a cosmic flip book where each page is a new wormhole opening and closing, and that creates this illusion of movement, even though nothing is actually traveling that distance.
Exactly.
Wow.
And I think that really highlights how differently we might need to think about this phenomenon. We can't necessarily apply our everyday understanding of physics to something as potentially strange and amazing as a microscopic wormhole.
This is blowing my mind. So if we entertain this idea even for a minute, if this paper is onto something, if there really are microscopic wormholes popping up beneath our feet, what does that mean?
That's the million-dollar question, isn't it? And I think if this theory is even partially correct, it completely changes our understanding of, well, pretty much everything. It means that wormholes might be far more common and much, much smaller than we ever imagined. Instead of being these massive distortions in space-time connecting galaxies, they could be these tiny ephemeral things flickering in and out of existence all around us.
It's like suddenly realizing there's a whole other dimension hidden within our own, and these Hessdalen lights, these little flickers and flashes, they're like glimpses into that hidden world.
Yeah, and who knows what else might be hiding there.
It's like we always talk about looking up at the stars to find the universe's biggest mysteries, but what if some of them are right here under our feet?
Yeah, or under our hiking boots if you're in Hessdalen.
Yeah. Exactly. It really makes you think. And it's like what we always say, it's amazing where scientific curiosity can lead you. You start with something like some strange lights in the sky, and you end up questioning everything you thought you knew about reality itself.
It's true. And this Hessdalen mystery, I mean, it really could be a game changer if we can figure out how to study it properly.
So where do we even begin? If we want to test this wormhole theory, we can't exactly capture a microscopic wormhole in a jar and study it under a microscope.
No, it's definitely not that simple.
Yeah.
But the paper does give us some pretty interesting paths for future research. One idea they propose is to look for something called magnetic anomalies around the lights.
Magnetic anomalies. Okay, so you're going to have to explain that one because I'm not sure I'm totally up to speed on my magnetic anomaly.
Sure. So basically the idea is that wormholes, even tiny ones, should create really strong magnetic fields. There's even some thought that wormholes might be the source of something called magnetic monopoles.
Magnetic monopoles.
Yeah. Have you heard of those?
I feel like I've heard of them, but I'm going to need a little refresher.
Okay, so a magnetic monopole, it would be like a magnet with only a north pole or only a south pole.
Right?
Which is really weird because every magnet we know of has both a north and a south pole.
Right, of course.
Like these unicorns of physics, we haven't actually found one yet.
Huh.
But some theories suggest they could exist. And if they do, wormholes might be one place to find them.
Okay, so let me get this straight. If we could detect even the tiniest magnetic monopole near a Hessdalen light, or even just a magnetic field that's acting really strangely, that would be a pretty big deal for the wormhole theory, right?
A huge deal. It'd be like finding that missing piece of the puzzle.
Exactly.
And that's just one idea. Remember we were talking about those ultrasonic sonic booms earlier?
Oh, right. We could set up a bunch of special microphones in Hessdalen that can pick up those super high frequencies that we can't normally hear and see if there's actually something going on that we're just not picking up on.
Exactly. And if we start seeing a pattern of these ultrasonic booms that seem to happen right when the lights appear, well, that would definitely give this whole micro wormhole idea a lot more weight.
And that could even tell us more about these hypothetical wormholes too, right?
Absolutely. We might be able to figure out how often they're popping up, how big they are. Maybe you can get some clues about how they form and disappear.
Wow, it's like we'd need to invent a whole new scientific field, like wormhole meteorology or something.
Wormhole meteorology. I
Yeah.
love it. And you're right, this kind of research would really push the boundaries of what we know about physics, which is
Yeah.
incredibly exciting.
Well, on that note, I think we've reached the end of our deep dive, but this is definitely a conversation we need to keep having. So what are your thoughts? Could these Hessdalen lights really be our window into a hidden world of micro wormholes, a dimension right alongside our own?
It's a mind-blowing thought.
It really is. Head over to our social media pages and let us know what you think. What questions does this raise for you? And if you had to design an experiment to test this wild theory, what would you do?
And for those of you who really want to go deep, we've included a link to the full scientific article in the show notes. Be warned, it's a bit of a challenge. But if you're as fascinated by this stuff as we are, we highly recommend checking it out. Until next time, keep looking up and maybe down too.